From far above our planet, one part of the Sahara looks like Earth is staring back at us. It is a vast, ringed formation so striking that many people call it the Eye of the Sahara, or even the Eye of Africa. And this is the part most people miss. What looks like a single eye is actually the exposed history of our planet, layer by layer. The Copernicus Sentinel-2 satellite mission has captured this extraordinary natural structure in the Sahara Desert of Mauritania, known as the Richat Structure. Seen from orbit, it appears as a huge circular pattern set in a vast ocean of pale, golden dunes in the Adrar region of northern Mauritania. At first glance, it looks artificial, almost like a giant target painted onto the desert floor, which is why astronauts have noticed it so easily for decades. For many years, scientists thought this massive formation might be the scar of a catastrophic meteorite impact. That story is dramatic and still widely repeated, but here's where it gets controversial. More detailed geological research now suggests that the Richat structure likely formed when a large, dome-shaped body of molten rock rose up beneath the Earth's surface. As this dome uplifted and then cooled, the rocks above were gradually sculpted by the powerful forces of wind, sand, and water erosion over immense spans of time. Today, most geologists agree the structure is at least 100 million years old, meaning it began forming when dinosaurs still roamed the planet. The Richat structure is composed of multiple concentric layers of rock that form a series of roughly circular rings, which is why it resembles a giant bull's eye when viewed from space. Because of this appearance, it has earned nicknames like the Eye of the Sahara and the Eye of Africa. With a diameter of about 50 kilometers, it is so large that it is actually easier to appreciate from orbit than from standing on the ground within it. Astronauts on crewed missions have used it as a recognizable landmark since some of the earliest human flights over Africa. Recent satellite views from September 2025 show two complementary perspectives of this feature. In one image, the colors are close to what the human eye would see, providing a familiar, natural-looking view of the landscape. In the other, a false color combination is used, where specific wavelengths of light are assigned different colors to highlight distinct materials and surface features. This kind of imaging might seem less realistic at first glance, but it can reveal patterns and geological details that are much harder to see in natural color. The layered rings of the Richat structure are made of different types of sedimentary rock that erode at different speeds. Over millions of years, the tougher, more resistant rocks have remained as ridges, while the softer layers have been worn down into valleys. This contrast becomes especially clear in the false color image. In that view, hard quartzite sandstones show up in shades of red and pink, forming the outer rings and several inner high ridges. Between these more durable bands lie darker zones where weaker rocks have been carved away more deeply. Interestingly, the central rings of the formation rise to about 80 m in height and are composed of rocks that are actually older than those forming the outermost rings, a detail that can surprise beginners who assume the center must always be the youngest part. In the natural color image, the darker region around the eye marks the Adrar Plateau, a large area of sedimentary rock that stands roughly 200 m higher than the surrounding desert. Beyond this, the view opens onto the Erg Ouarane, a vast field of sand dunes that stretches for hundreds of kilometers, eventually reaching across the border toward Mali. This helps show how the Eye of the Sahara is not an isolated anomaly, but part of a much larger desert landscape shaped by both rock and sand. Sand from the nearby Dunes Sea is clearly creeping into the southern portion of the Richat structure, a reminder that this is not a static fossil but a landscape still being reshaped by the wind. In that southern area, careful inspection reveals tiny specks that are actually individual trees and shrubs clinging to life along old river channels. In the false color view, these patches of vegetation stand out in purple, tracing the path of a dry riverbed and hinting at a wetter past. But here's a provocative thought: should a place like this be seen mainly as a scientific treasure, or also as a shared global heritage site that deserves stronger protection from future human activity? Some people still like the more dramatic meteor impact explanation because it feels more thrilling and cinematic, even though current evidence strongly supports the uplift and erosion story. Others wonder whether new data from future missions could overturn today's consensus yet again. So here's a question to you. Do you lean toward the romantic idea of a colossal impact? Or do you find the slow, relentless power of uplift and erosion more awe-inspiring? And more broadly, do you think remote places like the Eye of the Sahara should be left completely untouched, or opened up more to tourism and exploration? Share where you stand and why in the comments.